Hey guys, it's Angela here, and welcome to day 34 of 100 Days of Code. Today we're going to be doing a little bit of review, and we're going to be working with a trivia API to create a quiz app called Quizlet. Now, we're going to be using an API that we've seen before a long time ago called the Open Trivia Database, which contains over 3,000 verified questions, which we can pick from randomly to fill into our quiz application. Now, the purpose of building this app is to review what we learned about using API endpoints and sending requests to a particular endpoint to ask for some piece of data. And we're also going to be looking at what we learned about API parameters, switching in and switching out different inputs in order to get different pieces of data from the API. And with those things combined, we're going to be able to build our Quizlet app, which is going to be built using tkinter. So this is what it's going to look like, and we're able to keep track of our score and see the true-false question show up in the middle, and then we can select true or false. So I have no idea what the answer to this is, so I'm just going to guess. Oops, maybe not. The vapor produced by e-cigarettes is actually water. I think so. Nope. I am really bad at this quiz, so I'm just going to guess from now on. So there you go. I got one right and my score went up. This is a computer-related question, so I know that one. But essentially, this is what we're going to be building. And the questions that we're answering here come from the Open Trivia database, which contains loads of questions, so we don't have to make up the questions, and we can even select which category of questions we want, and also how many questions we want, and we're going to use this API to populate the questions in our quiz application. That's what we're going to be building, so if you head over to the next lesson, we'll get started by tapping into that API. To begin, head over to the course resources, as always, and download the starting zip file for today's starting project. And once you've done that, go ahead and unzip the file and open it up inside PyCharm. Now, if we take a look inside the project folder, you can see we've got a bunch of images, which is going to be used for the buttons. And we've also got a lot of the code that we had created in our previous quiz project. It may seem like it was a long time ago, but back in day 17, we learned about creating classes, and the project that we built to do that was a text-based quiz. And in fact, once you've downloaded and open up the starting file for today's project, you can actually run this program. So open up main.py and run it, then you can see the original format of the quiz application in action inside the console. We can type true or false, and it will give us some feedback, whether we got it right or whether we got it wrong, and also our current score. Now, this was great on day 17, but now that we know all about creating graphical user interfaces using tkinter, as well as a whole bunch of things that we learned about APIs just now, we're going to upgrade this quiz app to the next level. The first thing we want to upgrade is, at the moment, these questions are hard-coded. So inside our data.py, you can see all of these questions as a list of dictionary objects. And at the time, the place where we got all of these questions from was in fact the Open Trivia database. But what we did here is we selected the number of questions we wanted, we selected the category that we wanted, and then we changed the type to true and false, and we said generate API URL. And then once that URL was generated, all we did was we put it into our browser, and we got this data, and we put it into our question data. Now, this being hard-coded is obviously never going to change. So what we want to do instead is we want to get 10 questions from the Open Trivia database, but this time we want to make a request to the API so that we always get different questions and different answers. The idea of this challenge is to modify the code in the data.py file to get 10 new questions using the Open Trivia database every time the program is run. Here's what your code should do after you've successfully completed the challenge. You'll still get a console-based quiz, but this time the text and the correct answer came from the Open Trivia database via an API call. You'll see that any symbol like single or double quotes will not be displayed correctly just yet, but getting the API call working is the first step and the goal of this challenge. So what I want you to do is to set the number of questions to 10 and leave the category as blank, leave the difficulty as blank, but make sure that the type is set to true false, and then generate this API URL. Now remember what I said before, that the API endpoint is everything before the question mark. So this is the base URL that we're going to be working with. And then after the question mark, we've got our different parameters. So we've got a parameter called amount, which is set to 10. And we've got another parameter called type, which is set to the word Boolean. So you're going to have to think back to what you learned in yesterday's lessons and use the requests module to make a request to this API and passing in the required parameters. And then once you've generated the data from that API, then I want you to make sure that you reach into the data that you get back and grab the data that is in this format. And we're going to replace this question data with the actual questions that we get from the Open Trivia Database API. When we make the request to the API in our browser, we get back something that looks like this. So we have a 2-item dictionary. One is the response code and one is the results. Now the value for this key results is the list of dictionary objects that we actually want, and it looks very similar in structure to this. So that is what we want. So everything inside here, basically. Now we're going to still call it question data because elsewhere in our main.py, we're tapping into this data here. So make sure you name it the same. And once you've done this successfully, then you should be able to comment out all of this code here. And then simply run the program from main.py without any changes, and it should still work, but this time it should be using the questions and answers that you fetched from the API. This is a challenge for you, so I want you to pause the video, have a think about how you might do that, and complete the challenge. All right, so the first thing we need to do that we learned in order to work with APIs is to import the requests module. And once we've imported that, we need to get a response from the URL that we saw over here. As I mentioned, the endpoint is everything that's before the question mark. So let's put that in as the URL for our GET request. And then in addition, we need to add some parameters. So let's make our parameters a Python dictionary, and the key must match the key that's shown here, and the value has to match the value that's given here as well. So we've got 2 keys, amount and type. So these are both going to be strings, but their values can be numbers if it is appropriate. So amount sets the number of questions we want back from the API. And then the type sets the type of questions that we want. So in our case, we want the Boolean data type that matches this exact entry. So that way we get back true, false questions. Now that we've done that, we can use this parameters dictionary as the params. And then we want our response to raise an exception if there were any errors. And then we're going to get our response to give us the data using the JSON method. If this is our data, let's go ahead and print it and see what it looks like. We can run this particular file, data.py, by right-clicking and just saying run data. And once it's done, you can see we printed out the data. And the part that we're interested in is the value of this key results, because it contains the list of questions. That's the only part we're interested in. So in order to tap into that, we have to add a set of square brackets and then pass in the key, which is called results. So let's put that as the key. And now we're fetching all of the items that are the results from this data object that we get back. So now if I run this again, you can see we now have a list of question objects, which each contains a dictionary, and it looks now pretty much identical to this structure that we had before. Now, instead of printing this, we can save it as the question data. So now this question data has replaced this question data, and as I mentioned, we can run our main.py and it should now work just as it did before, but this time it's going to use questions that came from our API. The Cold War ended with Joseph Stalin's death, true or false? I think that's actually false. But notice how when we get the data back from the API, it's formatted in such a way that we've got certain symbols that have been encoded using this particular format, because all of this is meant to represent a single apostrophe. In the next lesson, I'm going to show you how we can format the text that we get back to turn this encoding into the actual characters that it should be. For all of that and more, I'll see you on the next lesson. In the last lesson, we managed to get our API to work and we got back some live data. But when we ran it, we saw that some of the text that we were getting back was formatted really strangely with these pound signs and ampersands, and it's not the actual text that we see. So what's happening here? Well, what we're actually seeing here are called HTML entities, and they're a way of replacing certain characters in HTML so that it doesn't get confused with HTML code. So for example, the less than symbol could be a part of HTML code, and instead of using that, we have to use the and, LT, and then semicolon. So if we look down this table, we can actually see this and quote actually stands for a double quotation mark. And that would make sense because it's saying quote Mario Kart 64 quote. And this #039, if we look up in this list, is actually a single quotation mark. And that would make sense as well because it would be Stalin's death. So how do we get hold of the actual human readable text? Well, we can use this tool called the free formatter to unescape the HTML result that we're getting back from our API. I've copy and pasted this part we've got here. And if I go ahead and click on unescape, you can see that it formats it into the original human readable format. And now it says in Mario Kart 64, Waluigi is a playable character. And if I paste the Cold War ended with Joseph Stalin, blah, 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 death, and I click unescape, then you can see it says the Cold War ended with Joseph Stalin's death, and it replaces that with an apostrophe. Now essentially we know what to Google, and that's kind of the first step towards solving any problem. So if we Google for unescaping HTML entities in Python, then the first result we get in Stack Overflow gives us the answer. We have to import the HTML module and use one of the methods in that module called unescape in order to unescape the text that we're getting back. The part where we're interested in this is in our quiz brain, because that's the part where we format it into our user answer. Let's change the question text to be equal to the self.currentQuestion.text. So this part that we have here, which is being put into our input, and we can use this Q text instead. But instead of using just the text that we get back from the API, we're going to import the HTML module. And we're going to use the method inside this HTML module called unescape to unescape this string that we get from the API. And now if I run this code again, you can see that this time, no matter what is inside the string, say an apostrophe in this case, or a double quote in this case, they're all being formatted correctly. There you have it. We started off with some strange characters, and after a bit of Googling around, we found the solution to turn them into human readable text. As a programmer, this is a skill that you have to really hone. This is something that is going to take you to the next level, to this intermediate plus level. You have to find out solutions to your own problems, and Google is your best friend. So now that our program works for text-based questions, it's time to upgrade this program so that it actually has a graphical user interface. You'll notice that in the project folder, there is a file called ui.py, and this is pretty much empty at the moment, other than a single constant which sets the theme color. Now, what we're trying to create is something that looks like this. So we have some sort of a scoreboard label, we have a canvas with a white background, and then on the canvas we've got some text in the middle, and then we've got a true button and a false button, each using the true and false images from this folder. Now we've seen how we can create graphical user interfaces using tkinter, but in this case we're going to do something a little bit different. We're going to create our user interface in tkinter, but we're going to do it inside a class. If you remember from day 17 where this project comes from, that was when we learned about object-oriented programming, and we learned about how to separate out our concerns, like the part that fetches the data, or the part that models each of the questions, or the part that handles the actual quiz functionality, and they're all separated in their own class. In order to create our user interface, we're also going to create our very own class inside this ui.py. So it's been a while since we've created classes, so I want to do a quick reminder session on how to do that. So we use the class keyword and then we provide the name of the class. Now in my case, I'm going to call this the quiz interface. And remember that the way that you name classes is what this is called Pascal case. So a capital letter, and then each word is not separated by any underscores or any dashes. So this is our class, and then we're going to create our init inside this class. Now, if any of this is unfamiliar to you, then make sure that you haven't skipped the lessons on object-oriented programming and creating and using classes in Python. We covered that in day 17. So if you skip that, be sure to head back before you proceed, because otherwise the rest of this is not going to make any sense at all. In our class init, we're going to create our user interface. So we're going to create all the buttons and all of the layouts. And we start off by simply creating our window. Now, this time though, instead of creating our window as just a simple variable, we're going to make it a property of this class. So we're going to add self in front of it. And then we're going to create it from the tkinter module. So let's go ahead and import everything from the tkinter module. And let's set our window as a new object from the tk class. Next, I'm going to change some aspects of the window. So for example, I'm going to change the title. So I'm going to set it to Quizler, which is going to be the name of this app. We can continue like this inside the init function, which remember is going to be called whenever we create a new object from this class. This is where we're also going to have our self.window.main loop, and that will set our program to run. In order to test this, we're going to go back to our main.py and we're going to import that class. So from UI, import the quiz interface, and then we're going to create that quiz interface down here. I'm going to call it the quiz UI, and it's going to be initialized from our quiz interface. Now, if you remember when we first learnt about tkinter, I told you that tkinter works by having this endless loop essentially. That's called the main loop. And this is a bit like a never-ending while loop. It's constantly checking to see if it needs to update something in the graphical user interface or if the user has interacted with it in some sort of way. So it will get confused if you have another while loop somewhere near it. So we actually have to comment out this while loop if we want this user interface to work properly. Now, whenever we want to test out our UI, all we have to do is to run our main.py. And once it hits this line, it's going to create a new object from our quiz interface over here. And once it does that, it's going to hit the init method and it's going to create our new GUI. You can continue coding up your user interface inside this init and it will work just as it did before when you created just a very simple tkinter graphical user interface application. Here comes the challenging part. I want you to create this particular user interface. And I've created a slide that shows you all of the padding or the sizing, the fonts, the background color, and all of the components that go onto this screen. I want you to pause the video here and see if you can create this user interface inside the init method of the quiz interface class. Pause the video now and give that a go. Alright, so we're going to continue where we left off here inside the init method. And we already started off our window property, so we're going to continue making that a little bit better. So we're going to call the config method on this self.window, and we're going to change the pad x and the pad y so that we add 20 pixels of padding on all four sides. Now, the next thing I want to configure is the background color. And as I mentioned in the slide, we're going to use this theme color that I've already provided here, which is a nice sort of midnight blue. So I'm going to tap into the background attribute and I'm going to set it to this theme color. Now, if we go ahead and run our main file, then we can see our user interface show up. And it's now got the background color and it's a little bit bigger because of the padding. The next step is to create this label up here, which is just a very simple text label. So let's go ahead and create it as a property of this class. So I'm going to call it the score label, and I'm going to create it from the label class of tkinter. I'm going to set the text as just score 0, and I'm going to change the color of this text, which is the foreground, to white. That way it'll actually be able to show up on this dark background. Now, in order for this label to show up, we of course have to give it some sort of layout. So we're going to use the grid, and I'm going to set the row to 0 because it's at the very top, and then the column to 1. So this way it sticks to the right. At this point, when we run it, because there is no column 0, it's still going to be just showing up on the screen on the left. And it's also got a white background, making it impossible to see the white text. Let's go ahead and change the background of this label to the same theme color. And that way, when we run it, we actually see our label with its white text. That's the label done. And the next step is to create our canvas. Remember that our canvas is really useful because it allows us to layer lots of things on top of it. And we can also set its background and size very easily. So we're going to create this canvas from the canvas class, and straight away I'm going to set the width and height. So the width is going to be 300 and the height is going to be 250, as we specified in the slide here. In addition, I'm going to change the background color to white so that it stands out almost like a card on the background. After I've created my canvas, I'm going to add some question text onto the canvas. So I'm going to create this as the self.canvas.createText, and this is going to have a single attribute called text. And I'm going to set the text to, say, some question text. So we don't actually have that at the moment. We'll just put in a placeholder. And if you want to, you can actually change the fill color of this text, which is the color of the text, to the theme color as well, just to make it all matchy-matchy. Now, finally, we're going to put our canvas onto the screen by giving it a grid. And this time we're going to set the row to 1, so below the score label. And then the column, I'm going to set it to 0. But then I'm going to set the column span to 2, so that it starts at column 0 and spans 2 columns to column 1. So now when I run this code, I actually get an error. And the error is super obscure, tells me tuple index out of range. Now, if you remember when we worked with tkinter, whenever we add an image or we add something to the canvas, we always have to provide a position as the first 2 arguments. And that is the tuple that represents the X and Y position of the text. We have to make sure that we don't forget that. So the first value is going to be the X, so that's going to be half of the width so that it's centered on the canvas. So that's 150, half of 300. And then the Y is going to be half of 250, which is going to be 125. Now if we run this again, hopefully we won't encounter the same error. And you can now see this card show up and our label show up on the right because it's in the second column and this is the first column and this canvas spans both columns. Now this text is a little bit small, so let's take a look at the slide and see what we need to change it to. So we want it to be Arial font, 20 point size and italic. Let's go ahead and add that to our text. And because it's getting a little bit cramped in here, I'm actually going to put this onto separate lines just so I can read it a little bit easier, like this. Now we can add that font argument and we're going to set it to a tuple, with the first item being the name of the font, and then the second is the size of the font, and finally we'll also make the text italic as well. So now let's run that again, and you can see the text is now much bigger and it's been formatted in the way that we wanted it to. The next thing we want to do is to add a bit of padding between this canvas and the score. So we want to add 50 points of padding here and probably 50 here as well, just to push everything a little bit further away from each other. To do that, all we have to do is to tap into the canvas grid and then add a single pad Y. We don't want to add any more padding on the x-axis. The original 20 is enough from the window, but we want to add 50 so that this way the canvas has some padding on the top and the bottom, like this, and it now looks a little bit more spaced out and easier to read. That's pretty much the canvas done. The last thing we need to add are the 2 buttons. So we'll add a true button and a false button, both created from the button class. And neither of them are going to have any text. Instead, we're going to create a true image from the photo image class, tapping into the file that comes from this folder. So it's images/true.png, and that is the image that we're going to slot in to this button. Now, in addition, I'm going to set the highlight thickness to 0. This way it doesn't have that weird awkward border around the button. And I'm also going to put this button onto the screen using the grid method. So now we're onto row 2, so below the canvas, and the column, we're going to set it to column 0. Now, depending on what you prefer, you can have the true button on the left or the true button on the right. It doesn't really matter because it's so big and it's quite easy for the user to see. I'm going to set it on the left, so column 0, and when I run this code, you can see that show up. So using the same method, I'm going to create the false button. Now we have a true and a false button, and we pretty much have our final user interface completed. Now, one of the things you see here is almost everything that I've created inside my init, I've given it the self dot. And remember from our lessons on OOP, this turns this into a property which can be accessed anywhere in the class. Now, some other things like the true image and the false image, I've not done that for because we're not going to use it anywhere else other than to set up our button right here. This hopefully will be a good review of what we learned about object-oriented programming and classes and objects, as well as tkinter and all of the new stuff around APIs. But this completes the user interface, and we're now ready to head over to the next lesson where we're going to fill some text into this question area. So for all of that and more, I'll see you there. Now that we've sorted out the user interface, the next step is to populate this with some questions that we got from our API call. So everything in our program is linked, and the place where we get hold of the next question is inside our quiz brain. At the moment, the quiz brain, when this method next question is called, will find the current question from the list of questions that it gets from data.py, and then it will serve it up in a input. This is what used to happen, at least, when we were still making our text-based quiz app. But in this case, we actually want to be able to output that question text and then get hold of it inside our UI.py. So let's update our quiz brain so that this question is returned as an output. I'm going to comment out this part of the code where we check the user answer because we no longer get a user answer from the input. Instead, we're going to take this question text and the question number, and we're going to serve it up as the output. So let's go ahead and return this entire string. And we can comment out this line of code. Now, inside our UI.py, we can call that method and put it onto this piece of text in the canvas. Let's create a method in here, which we'll call getNextQuestion. And this method is going to tap into the quiz brain and call this next question. So how do we get hold of the same quiz brain that we create in our main.py? Well, we could pass it in when we create our quiz UI as an input. So this quiz, which is created from the quiz brain, can be passed into the quiz interface. And to catch it, all we have to do is just to add another parameter in our init, which we'll call the quiz brain. And then we can create a property called the quiz, and we can set that equal to the quiz brain that we receive when we initialize this new quiz interface. So now when we have our getNextQuestion being called, we're going to tap into the self.quiz, and then we're going to call the method quizNextQuestion. Now notice how as I'm typing, you don't actually get anything showing up. And the reason for this is because even though we're passing in that quiz brain into here through the init, this file doesn't actually know what is the data type of this particular object that's being passed in. So one of the things that you can do is actually to add the data type when you create it as a parameter. So we could say that this quiz brain thing that's going to be passed in must be of data type quiz brain. And in order for that to work, we need to import it. So from quizbrain, import the quizbrain class. And now we can declare that when we initialize a new quiz interface, we must pass in a quizbrain object, which is of the data type quizbrain. And once we've done that and we've ensured this, then when we try to initialize this and we try to pass in something else, let's say I try to pass in the question bank, then this is going to give me an error, and you can see it says expected type quizbrain, but instead got a list. So this also ensures that we don't make any mistakes when we initialize the quiz interface. Coming back to here and scrolling down, now at this point, once we know the data type of quiz, then we can start typing next question, and you can see it shows up all of the methods that are available to the quizbrain object. We know that this is going to give us the output. So this is the question text. And once we get that, then we want to update our canvas. So we'll tap into our self.canvas and then call the item config method to change the item, which is our self.question text. And the thing we want to change about it is the text, and we want to set it to this Q text that we got from here. Now all that's left to do is to actually call this method, and we have to do it in our init so that when we first initialize our user interface, we don't end up seeing this some question text. Instead, we actually fetch the first question from our list of questions. But remember that everything has to go before the main loop, because all the code you write after this line is not going to be executed until that window gets destroyed. So let's put it here, and we can call self.getNextQuestion. And now if we run our code, you can see that instead of some dummy text, we're actually getting a real question here. The only problem is that it's not fully visible. One of the tricks that we can use is to get the text in a canvas to wrap by setting the text width property. Back up here where we created our question text, we can add another argument which is called width. And if we set that width to some value that is maybe a little bit less than the width of the canvas, then this question text is automatically going to go on to separate lines. I'm going to set it to 280 so that it's a little bit less than 300. So that way there's a little bit of padding either side. And now if I hit run, you can see the question now fits into the actual piece of code. There you have it. We've now created our getNextQuestion method, which is able to fetch the question text from the quiz brain by returning the question text that it got. Now we still have our principles of object-oriented programming maintained, where each module is responsible for its own thing. So the quiz brain is responsible for managing the quiz, getting questions, keeping track of score, and our user interface or our quiz interface class is responsible for putting those things onto the screen to be displayed. In the next lesson, we're going to take a closer look at Python type hints, and then afterwards we'll figure out how to get our buttons working. So for all of that and more, I'll see you in the next lesson. A long time ago, we've talked about Python data types. So the data types that we've been working with include things like integers, strings, floating point numbers, and booleans. And we've seen how you can interchange between different data types by casting. And we've also seen that in Python, the data types are flexible. So you could create a variable and then change its data type later on. This is known as dynamic typing. Now, I want to show you another thing that you can do with data types to make your code less error prone. Let's say that we were to create a variable, for example, a variable called age. Now, normally we would set it with an equal sign, but you can also simply declare its data type and then leave it as is. So this means that later on at some point, once you've actually gotten the age from the user or you've worked it out, then at that point you can set it. And this age now has to match the data type over here. So for example, if I was to change this to 12 using a string, then you can see that my PyCharm, my IDE, is now being very helpful in telling me that this age thing, ages ago when you created it, you said it should be an integer. Instead, I got a string. So this is quite helpful. You can do this with all of the basic data types. So for example, age is an int, name is a string, height is a float, and is human is a boolean. Now we can also specify the data type inside a function. So for example, if I was to create a function here called a police check, and it took the age as an input, and then inside the police check function, I would check, well, if the age is over 18, then maybe we would have some sort of variable called can drive, and we could set that to true. But otherwise, we can set that to false. Now we're going to return this as the output. So now at some point we can call our police check function, pass in the age, and if we print this out, you can see that it's going to give me false for age 12. And if I decide to say I'm 19, well, then we get true. We can actually use the output from this function to create a print statement, for example. So if the police check passes, then the policeman tells you may pass. Otherwise, you might have to pay a fine or spend a night in jail. So this is our function. And if we were to use this function police check at some point way down the line where we've forgotten what we created for this function and we can't look at it very easily without scrolling up hundreds of lines of code. Now, if at this point we've mistaken the input type and we put in, for example, 12 as a string, then this is actually going to give us a type error and it throws an exception, crashing our app. One of the ways that we can make our lives a little bit easier is by declaring a type for this input. So we do it in the same way as you see above. We can add a colon and then we can specify the data type of this particular input. So now when we actually write this line of code, you can see immediately we get this part highlighted, and if I hover over it, it tells me that this input expected a data type that's an integer, and instead I gave it a string. So this is a quick hint for us to fix our code before we even run it and get into trouble and create bugs. In addition, you can also specify the data type of the output of a function. And you do that by creating a little arrow with a hyphen and an angle bracket. So now we can say that this particular function is expected to return a Boolean data type. And my return statement does in fact comply with this, because can drive can only be true or false. Now, if I forget that this is what I need, and at some point I return, let's say, a string, then also I'm getting this warning highlight here. And when I hover over it, again, it's expecting a Boolean, but instead I'm giving it a string. This is known as a type hint in Python, and it's a feature that we got relatively recently from Python, and it has a lot of benefits, especially when you want your IDE, for example PyCharm, to help you spot potential bugs and keep your code safer and spend less time debugging and more time writing code. So we've seen how we can declare a data type for a variable like this, and we've also seen how we can declare a data type for the return type like this. That's all there is to it. In the last lesson, we got our quiz app to start displaying the questions that we were getting from our API. This question I landed on is pretty interesting. Nintendo started out as a playing card manufacturer, and I would love to know if that's actually true or false. So I'd really like these buttons to work, basically. If I click on one of these buttons, I want to be able to check my answer against the real answer that we got back from our API. So in this lesson, that's what we're going to get to work. So I want this to be a bit of a challenge for you. We know that we can add a command argument to our buttons so that it calls a particular method when it gets pressed. Now, when that method gets pressed, we want to go into our quiz brain and call this check answer. Now, this check answer method expects an answer to check against. Have a think about how you might solve this and get this to work so that we can start printing out whether if we got the question right or the question wrong. Pause the video now and try to complete this challenge. Did you have a go? Okay, here's the solution. The first thing I'm going to do is create a new method called truePressed, and also a method called falsePressed. This truePressed is obviously going to be the one that will be the command for this true button, and it's going to be self.truePressed because we're inside a class, and we have to make sure that there's no parentheses at the end of it because we only want to trigger this method when the button actually detects a click. In the similar way, we're going to add a command to the false button, and it's going to be self.falsePressed, and again deleting the parentheses. And now we can figure out what to do in here. We already have access to our quiz brain object in here, which is saved under self.quiz. When either of these gets pressed, then we can simply tap into self.quiz and we can call the check answer method that exists over there. And we can pass over true when true pressed is called, and then when false pressed is called, we'll pass in false. Now it's going to go into this check answer, pass that answer in, and it's going to print out whether if you got it right or whether if you got it wrong. So let's test that out. Let's run our code again and make sure that we don't make any silly typos like command. So let's run our app and see if we can answer some questions. Gumbo is a stew that originated in Louisiana. I think that might be true. And when I click on the button, you can see in the console, it's printed whether if I got it right or wrong. Now, while our code works and we can see whether we got it right or wrong in the console, that's not something the user will see. This is only something that's available to us as developers. So how can we give the user some feedback? That's what we'll figure out in the next lesson. We saw in the last lesson how we could see the feedback in the console, but what if we want to see the feedback on screen? What I want to be able to happen is when the user taps on true or false as an answer to the question, I want this card, which is our canvas, to give us the feedback. So if I click this and it turns green for a second, then that means I got it right. And then afterwards, it goes straight to the next question. And when I get the wrong answer, it should flash red. Instead of getting check answer in the quiz brain to print out you got it right or you got it wrong, we want it to return true if we actually got it right and to return false when we get it wrong. And we can delete these last two lines of code with the print statements. So now we can catch that when we call each of these methods, check answer and check answer, something like this. What we want to happen is we want to check whether if the user got it right or wrong, and depending on that, we'll give them different feedback. So we'll create a new method called give feedback. And this is going to take input in the form of whether if they got it right or not. Now, all we have to do is to call self.giveFeedback and then pass in the output to this method call, like this. And we can delete this line. Alternatively, you can use 2 lines of code for this, and you can pass in the value to this variable. These 2 lines do exactly the same thing. Once we get into this method, give feedback though, we need to change the canvas background to red or green, depending on whether the user got it right or wrong. And then after a delay of 1 second, we need to change it back to white so that we can then go to the next question. You might think that we can simply use something like time.sleep and then sleep for 1 second. But if you remember from previous lessons on tkinter, we mentioned that we can't mess with the time because we have this main loop going on continuously. So we have to use a tkinter method, which is window.after. And here we can set how many milliseconds we want to delay by, so 1000, and then what function we want to call. Have a think about how you might create this give feedback so that it has this particular functionality, where the user gives their answer, and if they got it right, then it's green, and if they get it wrong, then it's red. Pause the video and try to complete this challenge. All right, what we have to first check is whether if this variable that's being passed in is right, is actually true or false. If the user got it right, well then in that case, we're going to change the canvas and call config on it to change the background to green. However, if this is false, if they got it wrong, then we're going to change the canvas .config so that the background is red instead. Now, once that's done, then our canvas will be a different color, and then this is where we set up our timer. So after 1000 milliseconds, so 1 second, we want to go to the next question. So let's go ahead and call self.getNextQuestion. But in the same way that we can't have the parentheses when we set the command method, when we use this as an input, we also need to get rid of the parentheses. So now if we run this code and I pick an answer, then it goes red when it shows that I've got it wrong. And then after 1 second, it goes to the next question. Now, once it goes to the next question, that's where we need to reset our canvas. So we can say self.canvas and then do the same thing to configure the background back to white. And let's run this again. You can see I got it wrong. And then after 1 second, it goes back to white and it goes to the next question. And that completes the challenge. So the very last thing that we need to add is our scorekeeping capabilities. And all we need to do that is to pick out the value of the score from the quiz brain and populate it every time we get the next question. In addition to configuring the canvas, we're going to set the score labels config so that we change the text to the new score. This is going to be a F string, and we're going to say score, and then we're going to insert the self.quiz, which is the quiz brain object, and we're going to get its current score. Now you can see that every time we score a single point, then that value gets updated. Whereas if we get it wrong, then that score doesn't change at all. Now, the thing that we haven't seen yet is what happens when we get to the end of the quiz, because we know that we only have 10 questions. And once we get to the 10th question, you'll see that we actually get an exception thrown, index out of range. And that's because we've reached the end of our quiz, but we're still trying to get hold of the next question. So what we need to do is to check that we can actually get the next question. And to do that, all we need is an if statement, tapping into our self.quiz, which is the quiz brain. And here, remember, we have a method called still has questions, which is either true or false. Now, if we still have questions remaining, then we're going to go to the next question. But otherwise, what we're going to do is we're going to update the canvas text so that we change the question text to actually tell the user that they've reached the end of the quiz. Now, there's just a few more bugs to iron out. The first one is when we get to the end of our quiz, you can see that it shows up this text, but we can still press on these buttons and it changes the background for no reason. So we want to be able to disable these buttons once we reach the end of the quiz. And we also want to make sure that the canvas background is actually white again. So let's move this line of code out of the if statement so that no matter what happens, when we go to the next question, we always change the canvas background back to white. Now, in addition, we want to disable our true and false buttons. To do that, all we have to do is to tap into a keyword argument called state. And if we change the state of the button to disabled, then this will prevent the buttons from being pressed or activated. There you have it. Here's a upgraded quiz application that now has a graphical user interface which we can interact with, data that's completely generated from random and fetched from the Open Trivia database. And we can even modify these parameters to change up this quiz to our liking. So for example, if you want to change the category to, say, computers, then once we generate our API URL, you can see that it adds one other parameter called category, and we can change that to 18. So let's try that. Set the category to the number 18, and now when we run our code, all our questions will be computer science related. So have fun playing with your quiz app. And if you've modified your quiz app to make it more interesting or added some other features, then be sure to share it with the rest of us in the Q&A section.